In this video I want to introduce the concept of subscripts and coefficients. We use subscripts and coefficients when we write chemical formulas. For instance, one we're all familiar with is water, H2O. Now, hydrogen has a subscript, a number in the lower right hand corner of the element, at the foot of the element. This tells us in one molecule of water we have hydrogen, total atoms of hydrogen 2. How many total atoms of oxygen? Okay, oxygen, there is no subscript for oxygen, so it's understood to be 1. But since it's 1, we don't write it, so I'm going to erase it. In a molecule, in a formula for water, H2O, we have 2 hydrogens and 1 oxygen. That's if we have one water molecule. There's no coefficient, a number in front of this chemical formula. So it's understood to be 1. 1 times 2 is still 2 hydrogen atoms and 1 oxygen atom. Now, if I erase this 1 and I put a coefficient of 8, that's going to change the number. It doesn't change the formula. We still have 2 hydrogens for every 1 oxygen. But it does change the inventory, the total number of hydrogen and oxygen present. So how do we count the number of hydrogens? We look at the subscript. It's 2. This 8 multiplies every element by 8. So there's 2 hydrogens. 2 hydrogens times 8, we have a total of 16 hydrogen atoms now. The subscript for oxygen not being there, so it's 1. 1 times 8, we have a total of 8 oxygen atoms present. So this is the point here. Subscripts indicate the number of each element in a formula, and coefficients indicate the number of molecules, what we're talking about. Here we're talking about 8 molecules of water, but if we're just looking at the chemical formula for water, it's 2 hydrogens and 1 oxygen. Okay, let me go through a couple examples to bring this point home. What if I had a molecule of carbon tetrachloride? We have the elements present are carbon and chlorine. These are the elements present. Now, in this formula for carbon tetrachloride, we have 1 carbon, and this chlorine has a subscript of 4, so we have 4 chlorine. But if I add a coefficient, say, of 3, then I have 3 molecules of this chemical formula. So the inventory of the elements changes. Now, since this was 1, because there's nothing there, so we now have a total of 3 carbons. And how many chlorine atoms do we have total now? We have a total of 12. Okay, now let me give another example. Something that throws a little curve to it. What if I had beryllium hydroxide? This is the formula for beryllium hydroxide. So I'm looking at beryllium. Right now there's no coefficient, so it's understood to be 1. This formula tells me we have oxygen as well and hydrogen. Okay, so I have 1 beryllium atom present. Now, this parentheses, the subscript is outside the parentheses. This subscripted parentheses indicates that you multiply this 2 times every atom, every element in the parentheses. Oxygen and hydrogen don't have a subscript within the parentheses, so it's understood to be 1. So when looking at the total number of oxygen and hydrogen in a formula of beryllium hydroxide, it's 1 times 2 oxygen and 1 times 2 hydrogen. So beryllium's 1, oxygen's 2, hydrogen's 2. Now let's add a coefficient. Increase the number of this molecule to, we'll say, 11. How many beryllium do I have? The subscript is 1, so 11 times 1 is 11 beryllium atoms. Okay, how many oxygen atoms present? 1 times 2 is 2, 2 times 11 is 22. 1 times 2 for hydrogen, 2 times 11 is 22. The subscript is specific to the atoms that it's subscripted to, but the coefficient multiplies every atom in the formula. Okay, one more example. What if we had ammonium, subscript, phosphate? Okay, let's see. The inventory of this is ammonium phosphate. I have nitrogen present. I have hydrogen present. I have phosphorus. And I have oxygen present. There's no coefficient, so it's understood to be 1. We have a parenthesis with NH4 in it. The subscript for nitrogen is 1, so 1 times the subscript to the parenthesis is 3. I have a total of 3 nitrogen. For hydrogen, I have 4 times 3 is 12. Phosphorus, there's a coefficient of 1 in front of the molecule and a 1 for a subscript, so 1 times 1 is 1. Oxygen, 1 times 4 is 4. Let me make that a little more clear. Okay, now let me add a coefficient of 5. I now have 5 of this formula, ammonium phosphate, 5 of this compound. So now 1 times 3 is 3. I have nitrogen has a subscript of 1 times 3 is 3 times 5 for a total of 15 nitrogen atoms present. Hydrogen has 4 times 3 is 12. 12 times 5 is 60. Phosphorus has a subscript of 1. 1 times 5 is a total of 5 phosphorus atoms present. Now, 4 for oxygen, a subscript of 4. 4 times 5 is 20. So we have 15 nitrogen, 60 hydrogen, 5 phosphorus, and 20 oxygen atoms present when we have a coefficient of 5 in front of the formula unit, ammonium phosphate. This understanding of subscripts and coefficients is important for our next skill we'll be building upon will be balancing equations. The take-home message is subscripts indicate the number of each element in a formula, and the coefficients indicate the number of molecules we're talking about.